Hello everybody. Today my talk is Expanding Holographic Embedding for Knowledge Compilation. I am Zhitian Xu from Purdue University. This work is in collaboration with Yang Yuan, Zhitian Xu, and Ashish Sabharwal. We deal with knowledge graph compilation tasks. For example, given Bill Gates as the subject and lives in as the verb, we would like to guess what the object is. In this case, Bill Gates lives in Seattle, so the object is Seattle. As another example, Washington, D.C. is the capital of the U.S., so this time the subject is Washington, D.C. In general, there are two tasks that we deal with. The first is the tail prediction task, which given the subject S and the relation R, predicts the object O. The second is the head prediction, where we are given the relation and the object, and we would like to know the subject. We solve knowledge graph compilation task using compositional embedding, which we embed subject S, relation R, and object O into high-dimensional space. We then learn a composition function phi that models the probability distribution of seeing a particular subject, relation, and object tuple. There are classical approaches for knowledge compilation. One popular method, ResGo, forms an outer product of the embeddings representing the head and tail entities, then take an element-wise product with the relation matrix when computing the compositional function. As you can see, the number of parameters is dominated by the dimensionality of the relation embedding, which scales quadratically with respect to the embedding dimension d. On the other hand, we have the holographic embedding, which forms the outer product of the head and tail entities, sum up each diagonal line, and then element-wise multiply with relation embedding. Holographic embedding can be carried out efficiently using the Fourier transformation without forming the matrix of outer product explicitly. However, the number of parameters for holographic embedding scales only linearly with respect to d. You see, we have a gap in terms of the number of parameters between ResGo and the holographic embedding. Our contribution, the expanded holographic embedding, or HOL-EX, is a full interpolation between ResGo and the holographic embedding in terms of model complexity and computational efficiency. It combines the strengths of the two models. Holographic embedding multiplies the head entity with a random perturbation vector C1 before forming the outer product and in summing up according to the diagonal line, just like the holographic embedding. The final embedding is the concatenation of factors generated with multiple perturbation factors. We show in the paper that the model extrapolates from the holographic embedding on one hand towards the full ResGo model as you add more and more perturbation factors. We test our model on real-world knowledge compilation benchmarks. On FB15K dataset, our model outperforms originally reported holographic embedding by 14% and P-trans-E model by 4% on the heat at 10 metric.